Hello, everybody. It is once again pancake breakfast time. Our topic today is what is data management in the Kubernetes age? In other words, pass the syrup, Cassandra. It's pancakes time with Sam Ramji, Chief Strategy Officer at Datastax. Sam, good to see you here again today.
Good to see you, Alex. Long time no pancake.
Long time no pancake is right. Too long. And also joining us is Mya Pitzeruse. Hello, Mya.
Hey, Alex. I'm happy to be here again.
Mya is software engineer at effx. Thanks for joining us, Mya. And Tom Offermann, lead software engineer at New Relic. Hey, Tom.
Hi, Alex. Thanks for having me.
You know, we're here virtually, but it's always a good time for pancakes, is it not? I mean, I brought my pancakes. Did everyone bring their pancakes today?
I brought my syrup.
You brought your syrup? Sam, can you pass me the syrup, please?
Here you go, Alex.
Just hold on 1 second, Sam, because I need to get myself together here, and I want to I just thought I'd join you in your room for pancakes, Sam. How do you like that?
You stole my room, Alex.
Another pancake feat. I mean, this is pancakes as a service here. And maybe like pancakes are the new osmosis or like the new Star Trek kind of thing, or Star Wars spatulas for that matter. We can go quite a ways with the pancakes. So thanks for the syrup. I'm going to go back to my room, I think, for a minute. I feel comfortable here. But I want to say, Tom, did you bring any syrup? Do you have any syrup here today?
It would be great if someone could pass me the syrup.
Oh, okay. Yeah, sure.
Really, pancakes are just a delivery vehicle for maple syrup. So here you go.
Absolutely. You can never have too much. Thank you, Sam.
And Mya, I want to get an idea of what a Kubernetes pancake looks like these days. Can you give us a glimpse of the Kubernetes pancake?
Happy to. I figured since we had Kubernetes on the docket today, I would sit down and take a look at
We're
it.
not
and
worthy.
see about making
We're not worthy. And
some Kubernetes pancakes.
and do you have syrup? Do you need some syrup too?
I could use a little syrup.
Okay, good. Well, let me pass you the syrup over here. How about that? Here you go.
Thank you.
Oh, you're welcome. You're welcome. Well, why don't we just take a quick bite of the pancakes before we get into the discussion? Mine are vegan, gluten-free. I don't know about yours, but oh, wow. That's a good pancake. My gosh. A robot did not make those pancakes, not this time.
I missed the robot pancakes, but the robot never produced anything like Mya's awesome Kubernetes pancakes.
No, the Mya was on the robot was not nearly that advanced. So our topic today is about data management in Kubernetes, and we have Sam who brings that perspective from living in the land of Cassandra and living in the land of data management. We have Mya. Mya is quite knowledgeable on the world of gRPC. I look forward to hearing about kind of the perspective there. And Tom, I know you all are big consumers at New Relic of Cassandra and Kafka too. And so, my question is, Sam, where are we right now? Where are we in this world of data management? I don't really think that there's any kind of concrete kind of understanding that you get when you think about something that's so new, really, in that perspective. And we talk about data all the time, but there's lots more to it than just the data itself, isn't there?
Yeah, Yeah, and there's, nothing new under the sun in our industry, right? We're still working on a von Neumann architecture and building on Turing machines. All of that stuff is 70 years old. So, they had data in the mainframe era, they had applications, they had network and everything. But what we do see is every decade or so, there's a simplification, a change that makes it a lot easier to use and consume whatever the resource is. So, you see the 2000s and this era of scale out networking, right? You've got folks like Andy Bechtolsheim and others figuring out how can you create an addressable network space that lets you talk to billions of devices. 2010s, then you start to see the emergence of Docker standardizing containers on Linux, bringing a lot more Linux to bear, and then Kubernetes standardizing how you deal with Docker containers. So that's a decade of simplifying and standardizing how you do compute. So now we're at the precipice of the 2020s, and this feels like the decade of data. Now that we're building on top of those large, billion element scaling systems, how do we make data fluid? How do we make it containerized? How do we make it Kubernetes native and cloud native? Those are the kinds of things at the edge of practice that I see right now.
Before we go any further, I want to introduce my co-host for the show, who will be asking all the questions. Let's give a round of spatulas for Job Jackson. Spatulas. Hey, Job. Job, thanks for joining us. Job has a few questions out there, but before we get started with the questions, Mya, I had been doing a little research, and I saw that you did a presentation on gRPC and looking it through kind of this perspective of data management, and kind of concert with what Sam is talking about in terms of where we are right now. What is the interest in these new generations of these machine-to-machine technologies, such as you see with gRPC?
I think a lot of it gets into how do you efficiently move data around, right? Like a lot of the traditional systems have been bound to single machines. And with this kind of new era of compute, we need to start working on taking our data workloads and spreading them across them as well. Kind of getting back to Sam's points from kind of just a second ago, where we've seen kind of this nice new age evolution. And I think a lot of I think there's been a lot of lessons on the stateless side of the world that are starting to make their way down into the stateful side. And as a result, we're seeing some really healthy growth on running these really complicated stateful systems inside of these more ephemeral compute platforms like Kubernetes or Nomad, or even the managed ones in the cloud.
Yeah, that's kind of the story. It seems like that we're really been almost trying not to talk about until really most recently with these stateful environments. I mean, there's been a lot of work done with the interfaces, like the container storage interface and CNI. How has that impeded your work at New Relic, or how has it forced you to advance your thinking, Tom?
Yeah, it's interesting. I'm totally in sync with Sam here. I mean, I think looking at our evolution, both across the industry and within New Relic, Docker was such a huge leap forward because it kind of answered the question of what does it look like when you build software? What's the artifact, right? And we sort of standardized on Docker images as being the standard artifact. And now I think with Kubernetes, we're developing what is the standard way to deploy and orchestrate and manage those Docker containers. And so, and I think that the early activity in Kubernetes was around stateless services, and now I think we're kind of at the point where we're ready to tackle how do you manage stateful services, how do you manage databases, how do you manage data stores on Kubernetes, and that's pretty exciting.
And there's a really good reason for that, right? So if you look back at where Kubernetes came from, it was building on a lot of experience in containerization and large scale infrastructure management at Google. So when you look back to Docker, I remember meeting Solomon Hykes in late 2009 when he had first moved to the Bay Area. He was tremendously excited about what had gone into Linux containers. And if you start at the beginning of that provenance, it's 2007 when Google was contributing C groups to the Linux kernel. So creating this isolated security envelope around these different elements starts to become a deployment unit, and that's awesome. But Borg, as the internal system at Google was called, and it still is, was only half of the story. The other half of the story was how Google engineers were able to access state that was really well and automatically managed, and they didn't have to think about because of the stateful services teams. When Google went to open source the future of Borg, right, this perspective of Borg for everyone, Kubernetes, there was no parallel strategy for what to do with state. The idea there was, hey, as we increase the appetite for compute, people will use more and more cloudy stateful services, but you don't have to stuff that inside Kubernetes. Of course, what's happened, and I had a bird's eye view because I was VP of product management at Google Cloud Platform at the time, overseeing Kubernetes and cloud DevOps. We thought, well, we'll just take care of the compute and the data will take care of itself. But instead, as Mya said, right, that has pulled in a lot more orientation to, hey, why shouldn't data be as easy to use as the compute layer? So bringing statefulness to the Kubernetes environment is kind of the big challenge and opportunity right now.
Yeah.
I think like one of the interesting, points there is like, if you really look back, the test was like one of the first stateful workloads to support running on top of Kubernetes. And a lot of it stems from how the test was developed at Google running on Borg and like being able to leverage a lot of the existing semantics there, because the test wasn't really deployed any differently there. And I remember hearing somebody talk about it where they were like, as soon as Kubernetes like announced GA for like some of the lower level persistence components, like the test was like, yeah, we support Kubernetes for a deployment platform. So it's just like interesting history.
Yeah, it is an interesting history. And I think of like where we are now, for instance, like there's a lot of talk about GPUs and that's about managing data really, really fast and being able to train the models to run really fast. Does it, and then I think back to when container technologies first emerged, we were talking a lot about that speed factor and the ability for the portability factor. But how were you managing data then compared to how you're managing it now, Mya? I'm curious, and I love Tom's thoughts too.
Tom, do you want to start?
Yeah, sure. I mean, I think for me, the like before and after is really very much like what does it look like to manage data sort of in a traditional data center versus like what does it mean to manage it like in the cloud using Kubernetes, right? And there are there are just a lot more like capabilities in cloud Kubernetes, right? Like and it makes like there are more opportunities for automation that makes our lives easier and makes us able better to perform our jobs. I think about like what typical management tasks are in sort of the old world and old data centers, right? Like a node goes down, that becomes a page and a manual activity to kind of repair the cluster, to bring up a new host, to copy data over. In Kubernetes, in the cloud, using an operator that can manage a cluster, a lot of those tasks become completely automated and don't require any intervention of an engineer at all. And so like that sort of like capability is it's a pretty big leap forward.
I think there's a question of whether you want to manage two worlds or if you want to manage one world, right? So to your question, Alex, if you don't manage state in a Kubernetes native way, then you're kind of segregating it and you're piping it in from somewhere. One of the things that we did to bring Cloud Foundry and Kubernetes together was we took the Cloud Foundry service broker API and we cleaned up the IP and we contributed to the community, and that's called the Open Service Broker API. But still, a service broker means I've got my data over here and it's carefully managed, sort of more like pets than cattle by a set of folks who really know how to deal with the concerns of scaling out stateful services. And then you string a pipe and then you put that into your compute environment, and that's where your apps get at it. So that's kind of the old state of the art. What the pressure that Tom is describing is, why do you want to have two worlds? Why can't we take those esoteric rules about the data for data's sake and move them into being recipes and Kubernetes operators and automation. So you have one compute plane, one control plane, and a data plane, frankly, that's application aware, which is super hard to do if the two worlds are segregated.
Yeah, there's even coordination components from like an app dev's perspective too, where it's like, oh great, I'm deploying service X, but service X needs a database, a Redis cache, and it's like, how do you even go about deploying something that alongside your application if your application is running in Kubernetes, and then even like gluing all of the secrets into place. And if you're living in this split world, like one, your engineers now need to like maintain both Terraform and YAML, and there's not a lot of thought put into like the whole developer experience around it. And so like getting to this world where it's like, yeah, everything's kind of just packaged up together and like running in its own kind of isolated way makes a lot of things better. Not to mention when you start looking at like, how long does it take for a VM to boot up in comparison to like, how long does it take a container to start up, right? Like you have some, I don't know, carrots there, I guess. So
how does this affect the developer who's building out the microservices, for instance? And they used to work with one database, right? Now you might have multiple data stores working, working with each service in itself. You have that layer of data store there that you have to be managing. So how does that affect the developer?
Well, one thing you think about is, a good architecture has separation of concerns, right? So is every developer excellent at everything? Generally not. Even if you have a 2-pizza team, is everybody that you have in that 10-person team able to select, install, manage, deploy, operate the right 2 or 3 different data stores that you need? Maybe you need a NoSQL data store, maybe you need an SQL data store, maybe you need a time series database as well. These competencies then start to compost down, and you start to build a data platform. One of the interesting little known rules in Google is, right, we had, when I was there in 2018, about 44,000 engineers, extremely competent and made more productive by the platforms we gave them. And yet, only about 5% of the developers at Google were building stateful services. And if you were not one of the developers who built stateful services and you decided you were just going to roll your own, let's be clear, you were going to be in deep trouble. Because if you kind of do your data scaling and audit and security by the school of skin, knees, and bruises, you can put your company at a lot of risk. So separating the competencies into a data platform team is kind of the pattern that we tend to see with these kinds of classes of conversations, getting out of the tyranny of microservices 1.0, where you just say, team, go wild. And then you realize, oh my gosh, we've got data sprawl. We've got problems with our service level objectives. Like our uptime's not where it needs to be and we can't predict it. Then you start to say, well, it's time to get out of jail. Let's work with the platform engineers who can really sustain the kind of scale and observability and uptime that we need.
Before we go further into that discussion, we got Joe Jackson here. I think has a question from someone out in Pancake Land.
Yeah, well, in fact, we did get a question in from Domain Druids. And the question is, what needs to happen before you put data into Kubernetes? And she specified that the answers could be either people, process, or technology focused. So one goes out to the crew.
Who'd like to step up with that one? Mya?
Because I have gone through this probably 2 or 3 times. I've had my cloud provider like blow away my entire cluster. Getting backups in place is probably like the first big recommendation. Because like working through that workflow is like, for most operators, like pretty transparent these days. It's like added some additional config, get it going. But just because when we start to talk about like treating, clusters more like cattle, less like pets, like you can't get too attached to the data, just like living in that same cluster indefinitely. And so like having that data regularly backed up to like S3 or some other bucket service for, later restoration, like that can be used to spin up new clusters, that can be used to do complex migrations from like one version to the next, you name it.
So what are the storage? Yeah. So what are the stories you hear, and like from your own experiences too, about how that data loss happens? Is it in your cases, was it something on the cloud service side? Did what did you learn from that? What were some of the kind of the causes of these data losses?
So the big one for me was the cloud provider I was on deployed a change to their container storage interface driver, and it broke permissions for what is it called, ext4 on like the root of the driver, something like that. And so like it didn't break for every persistent workload I had. It only broke for a small handful of them, which was even more frustrating. And so like in the troubleshooting process, it wasn't clear like exactly why this happened. And so when I went and started rebouncing pods, they weren't able to load data. And then even once they did finally load data, the like boot record of the, this was Postgres, the boot record for the Postgres database was corrupted, and like it wasn't able to open itself back up. And so having just that regular nightly backup where it's like I could have restored would have been a huge lifesaver, but it doesn't fix the problem that like the cloud provider deployed a bug to their storage interface that then had issues with it, right? And it's like all software systems, right? Nothing is going to be 100% bug free. We can always just hope for the best. And so finding ways to think around those problematic cases are major.
Tom, you must have some war stories.
Yeah, well, I mean, I was just thinking about the question that, like, I think that there is a lot that we could take advantage of, like, building and deploying on top of Kubernetes. But we should recognize that, like, just having a Kubernetes platform available to us, like, requires quite a bit of work. And that means either, like, you have to have, dedicated people building and managing that yourself, or you need to have a cloud provider that and a managed Kubernetes service that you can trust. So I mean, it is complex. If you're doing it yourself, there's a lot to manage. So it's kind of like there is a layer that needs to like be in place, a foundation, before you're able to take advantage of some of the the goodness of managing stateful services on top of it.
So you all must have seen backup change quite a bit then over the past few years. Backup used to mean a lot. It used to mean quite something different when I first started writing about enterprise technologies, back in circa 2000, 2008, 2009. I expect that you learned a lot about backups when you were starting to work more in microservice environments.
I'm sorry, can you please repeat the question?
Oh, the backup question. The question about backups and how backing up data has changed. And what are some of the things that you've noticed and how you have to think about data backup now? I mean, you talked about a cloud service, right, where the interfaces didn't work so well. And so you had to think about the backups. But backups, I think, are treated a lot differently now than they were, even before the era of cloud, which wasn't so long ago.
I think there's been like a bigger emphasis on like testing your backups these days. Like I know that we had like a small effort kind of going through, like whenever a snapshot was taken of a database, that we would kind of go through and find a way to check some and make sure that the snapshot that we were taken were at least a little bit more consistent than what we were kind of initially expecting before. The kind of big thing there was like, you could trust that your database is like snapshotting properly, like, and just like say like, yeah, the database snapshot should be fine, or you can always just verify it, right? But that's just been the bigger way that I've seen it change. I don't think it's really changed too much. There is more of like a concept, I think, for streaming backups versus like doing the periodic one-time snapshots. And that's definitely for the larger scale stuff that we've been working on.
I've had a chance to chat with folks from Mya Data, who are the maintainers of OpenEBS, and Cassandra.io, which was recently acquired by Veeam, and the folks at Ericto. And they're all focusing on Kubernetes native data management, including backup. Also, Eric Hahn, who's now at NetApp. And of course, you saw Portworx acquired by Pure Storage recently. And I think the change that you're going to see, that you're already seeing, is radical application awareness as defined by Helm charts. If you can't read the Helm chart, then you don't understand the exploded application topology that Kubernetes is bringing. And then you can't really fully understand what you want to back up and then how to restore it, because all of the cardinality changes, right? How many of this for how many of that? What actual nodes are these different processes running on? What data access do they need when you're in a restore situation? So I found it quite fascinating to talk to those folks as well about the integration that they've had to do with Helm charts and application architecture awareness in order to execute the restore and the backup, or the backup and the restore process correctly.
Well, great. Well, we're getting a little bit into the weeds a little bit, and I'd love to bring it back into some of the the main points here about how we think about data management. I would love to just get a perspective on how you think it's going to change over the next few years. And Tom, is there any glimmers of what change you see coming? For instance, the need for new tools or new capabilities, with the operators or whatever it might be.
Yeah, I mean, I think we're really at the beginning of establishing this operator pattern for managing data stores on Kubernetes, and those operators are only going to get more and more capable, right? I think right now, like, they're very good at deploying a cluster, scaling it, recovering if a node goes down, like I was describing. But like, what's exciting, at least in the Cassandra community, is like all this activity around like the next set of things that every operator needs, right? Like having backups be automated and built in as part of the operator, metrics, those kinds of things. Like, so the operator, like, that pattern is being established, and we're only going to like continue to add more and more capabilities to it. How's that pattern emerging for you, Sam?
We've learned that we've had to put a lot more day two capabilities in our operator, right? So as the folks from CoreOS who first created the operator pattern would say, that there's a big difference between enablement, kind of the day one, like, look, I can run this database on Kubernetes, and day two operations, like, will it stay up for days and weeks and months and years? So as both Tom and Mya have mentioned, right, like backup and restore, including a lot more different components around the database is important. So one of the things that we found is we've run large-scale Cassandra, multi-tenant and single tenant in all the major clouds. We've built a service called Astra, which is basically large-scale cloud-based Cassandra. It's all on Kubernetes, and we found that we had this kind of ecosystem of other projects that we've had to pull on and build in order to make it run properly. So packaging all those things into a distribution, which we call Cassandra, K8SSANDRA, includes things like Medusa and Reaper and metrics collectors, as well as signals that can be raised to Kubernetes and beyond, getting out of this idea that the database itself is a monolith and kind of inverting it a little bit, like making the cluster management a little bit more obvious, waiting for Kubernetes to pass you control again, and having all the affordances that you need around the kernel of the database in order to actually scale the operator pattern. So operator is great, not quite enough. You need really a distribution of operator helpers that can make the database work well in a Kubernetes control plane.
Mya, I'd love to hear your perspective, and then maybe we can go to Joe for a question.
No, I completely echo that. You see a lot of it in some of the well-supported operators today. I've gone from the Press Labs MySQL operator, Zalando's Postgres operator. Most of them come with some kind of like sidecar or code process that's able to kind of like help with the database administration and like kind of cutting processes.
Sidecar is a good way to think of it, isn't it? As a code process, isn't it?
Yeah. Like, I mean, the whole orchestrator stack and what is it? There's a set of tools all around MySQL, like the Percona setup, like all of that. It's all typically done as a sidecar. And kind of getting back to, I think, one of your earlier questions around like how did that used to kind of get managed versus how does that get managed in kind of that Kubernetes world? It's like running those sidecars on like systemd were always a pain.
Well, Well, good. Well, Joe, what kind of question do we have from the crowd out there in Pancake Land?
All right. Well, I'm very curious. Someone is very curious about Astra serverless and how that works with gRPC and data streaming. So maybe, Sam, you could talk about how these things are interrelated.
Sure, I'll do my best. So serverless is partly about how you get the unit economics of a service down. Something that we hear a lot from cloud users, as well as people who are building on-premises environments that need to have cloud-like economics. Do you have to commit to one server? Can you just run as much workload as you want, and will it auto scale behind the API? And I think that's also the same question. For the idea of gRPC, right? So one of the things that you'll find in distributed systems architecture is gateways are really helpful, right? So as you started to look at how do we manage all these services, how do we get the right service tone, you see Matt Klein and the Lyft folks open sourcing Envoy, and Envoy all of a sudden becomes kind of a data service proxy for most of the microservices that you run on Kubernetes. And that gives you a really nice place to attach into any of the service meshes that you care about, whether it's Kuma or Istio or anything that follows the SMI, some of Edith Levine's work at Solo. So this idea of a gateway, right, a service control plane, a service mesh, all these things connect in by having a really good service proxy with Envoy. So being able to start thinking about a data proxy, enabling people to build data meshes is really important. Just because you wrote the data a particular way doesn't mean you should always have to address it the same way. So we're seeing people building things out. We're seeing this in Netflix. We're seeing this Apple. We've copied the pattern and released an open source project called Stargate, where you should be able to point it at your existing data store and then say, hey, you know what? I want a JSON view of this that feels more like a document. I want a REST view of this. I want a GraphQL view of this. And most importantly, for the high scale services, a gRPC view. And that's something that Mya is far more expert on than me to explain why you would want to be able to have like these personalities, particularly gRPC for the kinds of application affordances and sort of operator, sort of sanity, perhaps, of being able to scale effectively.
Now, Mya, I understand that there's some work going on with gRPC around, I guess, in effect, using it to perform load balancing and maybe API gateway functions. What's going on there?
So gRPC's had like load balancing in, I think, from like day zero or something like that. They've always been able to load balance across their backend instances. The big thing I think that's, the big thing I think that's been changing more recently has been its tighter integration with the XDS API. So kind of hitting back to that service mesh. One of the core components in the service mesh is the actual coordination APIs that are used to direct traffic from instance A to instance B. And so when you talk about a service mesh, most people talk about the proxy-based mesh, which is like an application talks to local proxy, which then handles the MTLS, the load balancing, so on and so forth to the backend instances, which then have a corresponding proxy in the backend instances. As you can imagine, there's a lot of workloads that this adds kind of like too much latency around, like in particular around like kind of persistent workloads, where if you had to jump through those hoops every time, it's going to become a hassle. The benefit to gRPC is being able to kind of like direct all of that without necessarily needing those proxies in the mix. And they announced that. Go ahead.
Oh, I'm sorry. So it could potentially replace a service mesh at some point.
Yeah, that's like one of the big kind of proponents. I don't know if I would say replace a service mesh, because the service mesh is kind of very, very complicated. We talk about it in probably two key planes, right? The data plane and the control plane. And it doesn't replace the control plane component. It only replaces kind of the data plane component of the actual structure. So.
It's a lot about performance, isn't it, Sam and Tom? Tom, performance, it has to be a major consideration, and gRPC and Cassandra, has a role in optimizing performance. But what are the other performance issues that you see cropping up?
Yeah, so performance is definitely speed, but also related ability to handle high volumes of data. Those are the things that we care about. Like that's sort of at the top of our list, right? Like how fast can we write data is the thing we care about the most. And something like Cassandra works really well for us. As in terms of like Cassandra and gRPC, like for our use case, we don't really. We don't have a world where like many services are talking to our Cassandra cluster. Like all of our writes are coming through like one service, and like again, it's designed for sort of high throughput, write as fast as you can. And our queries on the read side are kind of similar. But yeah, I agree that like performance is the number one concern when we're looking at a data store.
And the useful thing about coupling something like gRPC with Cassandra is that you think about the raw throughput that you're looking for from a database, and then you mash that against traditional binding approaches, and you go, well, how much time am I spending marshaling and unmarshaling the data? And then you think about how much developer time you're spending building out SDKs for each language to make the data endpoint consumable. gRPC kind of by design auto-generates stubs. It lowers the barrier of access. It also lowers the expectations for how you're gonna talk to the database. So it's kind of, there's a nice harmony between gRPC and Cassandra for sure. But Cassandra is not the only database that is going to benefit from gRPC. Tom uses Kafka, and you use, of course, the New Relic database, right? The internal NRDB, which is a pretty darn strong time series database.
Yeah, absolutely. I mean, we have, we store many different types of telemetry data, and we try to choose the right data store for each different data type, and make sure that it's appropriate for the given shape of the data.
I today at AWS reInvent, Werner Vogels did his keynote, and he had an interesting talk about bringing strong consistency to S3. Evidently, they can do strong consistency now, whereas before it was eventual consistency. You didn't get the info about the data you placed in the S3 bucket right away. And in general, he had said that consistency on distributed systems is a really hard problem. They worked a lot of years on it. And I'm kind of curious as to, is this true? And is this a problem with, I know we're talking about performance, but is consistency a big kind of stumbling block for using Kubernetes or any distributed system?
Why, you have any thoughts on that?
Anytime you talk about the distributed system, you're going to hit issues with dealing with CAP. So the CAP theorem, consistency, oh gosh, I always butcher this when I haven't looked at it in a while, and I always feel like a fool.
Yes, consistency,
availability, network, and it's like, which one do you choose in the event of a network partition, because the network partition is inevitable, right? And so, how do you favor that? And most storage systems that we talk about today favor availability over consistency, right? And so that's how you end up with, or consistency over availability. And then you typically pair that with like an AP system, like your auto scaling service, right? And that's how you're able to kind of like balance those trade-offs. But
yeah, that's actually a great sort of focusing point on Cassandra, right? Because the database itself was invented, 12 years ago. When Facebook was trying to figure out how to do Facebook inbox, they had this really big problem with availability as they were trying to compete with basically Microsoft Outlook for email. So you can imagine how hard it is getting the Wayback Machine, right? It's 2007, 2008. The iPhone has just come out, and the world standard is you're using offline email clients, particularly Outlook, tied to Exchange, which does caching. So how do you compete? Well, you have to be hyper available. So they took the AWS Dynamo white paper and said, how would we build a coordination layer that looks like Dynamo? And then they took the Google Bigtable white paper and said, how could we have this write privilege system where writes are equally as fast as reads? And by taking those ideas and algorithms together, they ended up creating Cassandra, which is pretty interesting. One of the things that you'll find is any distributed system does have consistency issues. So what do you do about it? And in fact, there are tools in the Cassandra ecosystem that focus on what's called the repair process. Repair is actually an abbreviation, and I'll stop here, for anti-entropy, consistency, and repair. So realizing that entropy is a thing that happens in distributed systems, you have to have a process that runs every so often to say, like, is everybody okay here? Like all the 12 or 20 or 200 nodes in the cluster, we got the, oh, we don't got this. Let me go fix that. Let's get the entropy out.
When entropy happens, what do you do? I think there's a question there for the ages. And I'm also curious about how this, evolves when we start thinking about, the evolution of machine learning, which is really becoming quite a big part of how we think about distributed systems and distributed architectures. And we're just seeing it from the news stack, just seeping in everywhere. And so I'm curious on how, this discussion really reflects on that. Who wants to take a shot? Tom?
Well, not coming from a machine learning background myself. I mean, I think one of the big things about it is just the volume of data that you have to manage, right? And so any sort of, any sort of machine learning experiments modeling that you're doing is what's required is having like a huge volume of training data to run that on. And so really the question is like, what makes it easier to manage high volumes of data, right? And I think that's where, like, the tools, databases like Cassandra, and being able to manage those in cloud in Kubernetes, it allows you to scale out your data store so that you can run that, like, machine learning on top of it.
I think a big thing is like managing your resources efficiently, right? Like if you look at kind of the history of machine learning, they started on like the MapReduce side of the world, where it's like we can't keep all of this data in memory, so we have to map it out to all of the worker nodes and then reduce it down into something that we can actually understand. With things like stream-based APIs inside of gRPC, you can actually get more efficient access to your data, both like at the database layer as well as during processing. And it helps keep your resource footprint lower. It helps you do a lot more things kind of to that point of efficiency. But you can also just manage like the volume of data just significantly better.
Yeah, and that's a great sort of interface through which to look at, can you feed the gRPC front end, right? Can you feed the gRPC API at the speed that the clients can consume it? So that speaks to the data stack. It also speaks to kind of the Kubernetes wave that's kind of sweeping through the world. One of the first products that I had the privilege of launching at Google was the tensor processing units, which is all about ML. So the question, why would you use a TPU, is the same answer as why would you use a GPU, which is, I want my model to get trained before the universe dies of heat death. So how can I just go and grab a whole bunch of specialized resources, GPUs, whatever, and get my training time down from maybe 200 hours to 20 hours or to 10 hours? Now, the liminal factor there, or the limiting factor there, may be your data throughput. A very basic machine learning model to learn a whole bunch of images. We've seen cases where typically you're going to want 6 gigabytes per second, maybe 10 gigabytes per second of throughput. That's actually fairly high as raw throughput goes, but it's appropriate for being able to get your machine learning model trained fast enough. You combine that with geospatial, multidimensional data that you're all trying to train on at the same time, you really want high throughput so that you can train your model fast enough. And the thing to think about here is this isn't a flow process. So some of you may be familiar with Kubeflow, the ability to put your TensorFlow on your Kubernetes clusters. Again, that's all about being able to iterate and have kind of a CI/CD approach to machine learning. You've got a model in production, but you want to update your model just like you update code. How do you iterate the improvements in your model? How do you learn those? How do you do the training phase? How do you deploy that back to production? And how does that system end up pulling on similar classes and speeds of data that it was trained on? This is where we start to try to harmonize the operational and the analytical systems so that we're not doing this crazy data lake export of all the operational data, training your models on something that you're never going to see in production, and then hoping, right, on a wing and a prayer that somehow it's going to make good decisions as it powers your API. So all that stuff is really, really challenging. I think over the next couple of years, we'll start to see data engineers, ML ops, data ops, all start to standardize in Kubernetes They're going to ask, what's a container for data? And how do we make this stuff an order of magnitude simpler? So we got a little ways to go, but it is going to be about speed and consistency.
Hey, I wanted to ask Sam about Stargate, which Datastax just released. We've been getting a lot of buzz about it at the new Stack, and the company describes it as the first open source API data gateway for modern data applications. And it has, I believe, you could do GraphQL, you could do JSON. Well, can you explain what it is and the value there?
Yeah, basically, it's an attempt to create an open source project that could talk to any backend. The backend we understand, of course, is Cassandra, right? It's right here on the shirt, but it should be able to be pointed at any backend. And it's a pattern, as I mentioned before, that we've seen at Netflix, we've seen at Apple, where you have a range of different application development communities. They have different APIs that they want to be able to talk, or API styles that they want to talk to the data through. How do they get there? So what we've learned in computer science is any problem can be solved by adding in one level of indirection, right? That's how virtualization works. So you can think of that as, what does a service proxy do? What does a data proxy do? Stargate's intent is to be a proxy or a grown-up proxy, like a gateway, where you can modularly add new personalities, right? So you could do, a WASM or a Rust sort of module to say, okay, here's the underlying protocol that I use to talk to the data store. Here's how I want to render it. And then let me run it for every request corresponding to the same security model. And can I run it at line rate? So, we're pretty stoked to see the uptake so far, right? It's more important to land and be useful than it is to launch, right? You don't want to crash and explode on the landing, no matter how pretty the launch was. So it's our hope that a lot of people will grab it, that it'll be a multi-party open source project that helps people with the developers' affordances to data that's being hosted in Kubernetes.
Would that be something? How do you see there's something of value to either you, Tom, or for Mya?
Yeah, I mean, I think that's I think that's right. Like, I like the emphasis on, right, like making it easier for developers to access the data. And then there are different ways of doing that. I think, like, internally we've solved the problem by sort of like funneling all requests or reads or writes through a certain set of services that sit in front of our Cassandra clusters, and other services that need to access that data all funnel through those services, right? So we've sort of like worked out a solution that makes sense for us. But I think what we're talking about here is that, like, building a sort of more open source solution to that problem, which is like, lots of developers want to access the data, but they want to do it in different ways. And how can we make that possible?
Mya, any last thoughts before we go?
Can't tell you how many times in the last 2 weeks I've turned to our CEO and said, I really wish we didn't write our front end API in GraphQL. I've worked on GraphQL for a few years, and it's like, I've only really ever done the backend side of it, and I've never been big on the like querying side of it. But when I started to get into effx and started to look around at a lot of the product analytics and how a lot of that was being driven currently, a lot of it was going through their existing GraphQL layer instead of going to the database. And every time I was like trying to put together like some kind of query, I'm like, gosh, I just really wish I could write SQL. And so, like, the kind of benefit here is, like, we don't really care how you want your data. Like, you tell us how you want your data and we will give it to you. We just have to take care of retrieving it from the back end. And that's kind of like one of the simple things here that's like really appealing, where it's like, now that kind of like, again, like that debate is like over, like, do we write a GraphQL endpoint or do we write a gRPC endpoint? It's like, no, like, here's something that gives you it all for free. Go.
Yeah. Porque no los dos, right?
Yeah.
We should all be happy. It's all about reducing developer and operator toil, right? So anything that makes people's lives easier end up getting used. And the pattern of writing a microservice in front of Cassandra so that you can render the data the way that, like, it probably should be rendered automatically, that doesn't seem like a great use of people's, like, irreplaceable heartbeats. So if you can have something that does it gets it 90% right for these different modalities, right? These different ways of talking about data, then just let the robots do the work, right? And then let the humans do what we do best, which is like talk to each other and imagine.
I think
Maybe
that's a great way. I'm sorry, what was that?
I was just going to say it even just pushes it closer to like that kind of Google feeling, right? Where storage is kind of solved, right? You're not really like working directly with the storage layer. It's like, nope, you want a manifested view or a manifested like interface on top of it. Like you go and build it in very similar ways, right?
Well, I like how this is ending. We should all be happy and let the robots do the work. I think it's a good way to end the year here. This will be being published in January. It seems so far away right now, but thank you so much. It's a great way to end our year with a pancake breakfast with some of the smartest people we've talked to here at the New Stack. So thank you so much, Sam Ramji of Datastax. Mya, your perspectives are excellent. We're so happy to have you join us for a second breakfast here. Mya Pitzeruse, software engineer at effx, and Tom Offermann. Tom, thanks for your perspectives at New Relic. And, let's give everyone a spatula here, Way to go. Way to go. Thank you, Job. Thanks, everyone. May the pancakes be with you.